In this video, we are going to see how chi-square test is performed in SPSS. So here I have a data set. The data set, it's a quite large observations are present here. So let me just tell you what it is about. We have customer ID and region for geographic indicator. In that we have like 5 zones and similar data: town size, gender, male or female, age, education, lots of things are there. And this is a telecommunication data collected by the telecommunication provider probably. Mostly it's hypothetical data. So churn is another variable which tells whether the person has switched provider within last month or not. So it has two answers, yes or no, obviously, and gender is also there. So we are going to test using chi-square test that whether this gender and churn status they're independent or not. So in other words, whether the person will churn or not, the probability or the chances depend on whether the person is male or female or not. So let's conduct the test. So we go to analyze, then descriptive statistics. Then let's go to this cross tabs. Click on cross tabs. So in the cross tabs, I'll just redo it once again. In place of row, we will be putting gender. In place of column, we will be putting switch providers or not. You can do the other way around also, that you can select gender in place of columns and churn in place of rows. No problem with that. So let us go to now statistics. In that, this chi-square needs to be clicked. Then go ahead and press continue. Press cells. See, observed and expected, these both should be clicked. Usually the expected is not, by default it is not clicked, so you have to click on expected, then continue. Just to double check that in statistics you have chi-square clicked or not. It's clicked. So now let's press OK. So this is the output. The first table says it's the case processing summary. How many total number of observations were there? Like 2,500 observations are present. And in this table, it gives you the actual count and expected count. So this is basically the contingency table that you see in the theoretical question. And in the last table, the result of chi-square test is given. You can see the Pearson's chi-square value is given to be 5.173, and the p-value, that is asymptotic significance, is given to be 0.023. The rest of the things tell something that we right now we don't need. So the significance or the p-value is 0.023. So if you are given alpha value of 0.05, then we have to accept the null hypothesis in this case, which is the variables are independent. And in case you are given 0.01, then it's certainly higher than that, so we have to reject the null hypothesis. So depending on the level of significance given, we will be having different opinion from chi-square test in this case. However, for our case, let us consider that the test was supposed to be done with 1% level of significance. So let us go to the word to write down the interpretation. So beforehand we have written the null hypothesis, which is gender and churn are independent. Alternative hypothesis, gender and churn are not independent. And we just mentioned that this we will copy the table into this Word file, like this one first, and also the next one. Actually, from the next one we are going to conclude. I think it's a little bit bigger than expected, but we have the information, we have all the information here, so we can. So we have to write from the above table the chi-square statistic is 5.173 and the p-value is 0.023. Therefore, we reject H0, or we infer that the variables are independent. That means accepting the null hypothesis if alpha is equal to 0.01, since obviously 0. This p-value 0.023 is greater than 0.01, so we need to accept the null hypothesis, that is the variables are independent. Also, just to mention, if alpha is equal to 0.05, then we accept H1, that is the variables are not independent, since 0.023 is less than 0.05. So this is the interpretation, and this is all about the chi-square test. And also we may have one more type of chi-square test, that is testing whether a given theory is fitting our data or not. So let us look at one example for that, so it will be clear. Let's say that we have thrown a die 300 times, and we need to test whether the die is unbiased or not. So for the variable, first will be the outcome. So this is a numeric, and it should be nominal, because here the possible outcomes are 1, 2, 3 up to 6, and here we are going to write the frequency. Frequency will be in scale. So in case of outcome, should be any one of these 1, 2, 3, 4, 5, 6, and frequency. The frequency, suppose that one out of those 300 times, one came 40 times, 2 came 60 times, 3 came like 45 times, 4 came 55 times, 5 came, let's say, 58 times, and 6 came 42 times. So from this information we have to test whether the data is independent, I'm sorry, the die is unbiased or not. So first look at this one thing, that the frequency here in this case, the frequency will be considered as a raw data by SPSS. So we have to tell SPSS that this is a frequency, these are frequencies and not raw data. So to do that, we will click on data and then click on wait cases. So we will be waiting the cases for outcome, and will be wait cases by this variable frequency. If you're not sure, then just go ahead and see the video, see that portion of the video once again, that how we are doing. So going to data, then wait cases, outcome, wait cases by frequency. So once we have done this, let me close this output. Once we have done this, now we are in a position to run the chi-square test, and this time we are going to go with analyze, then non-parametric test. Then we'll go to legacy dialogs, then go to chi-square. So here we have a test variable list, and we will be just simply putting outcome here. Remember, frequency is not a simple variable now. Frequency is considered as frequency by SPSS. It is not raw data. Obviously, if the die is unbiased, we should be having all same expected values. So all for expected values, all categories are equal. Otherwise, we have to manually enter the expectations. And in this case, we are not going to do anything else. Just simply press OK. So in this case, we have also obtained the table and the chi-square value. See the expected table, we have 50, because if the die is thrown 300 times, if it is unbiased, then all the outcomes are equally likely. So all the outcomes should come 50 times each. And the value of the test statistic is 7.560. Degrees of freedom is also given, that is 5. And the p-value is 0.182. So easily you can understand that 0.182, it's quite bigger than 0.01 or 0.05. So we will be accepting the null hypothesis. So the p-value is higher than alpha value, so we'll be accepting the null hypothesis that the die is unbiased. So in this case also, the null hypothesis is that the die is unbiased, and we should be continuing with that. The interpretation will be written in a similar manner that you can understand, I believe. And that's it for today. Thank you for watching.